Hello everyone, we are from Group K, and in this video we're going to talk about the construction technology of retaining wall. Okay, before we start, let me introduce to you my group member. The first one is Clayrista, Haziq Haqimi, Haziq ZULHILMI, and the last one is me, LING. Okay, so let us start by introducing what is retaining wall. Okay, the retaining wall defined as the structure that retain any materials and prevent it from sliding or erode away. And in other words, it was designed so that to resist the material pressure of the material that it is holding back. Okay, so there are many types of retaining wall, and the first one is gravity wall, which consists of reinforced concrete wall, such as concrete cantilever retaining wall, the precast concrete retaining wall, the pre-stressed retaining wall, and the second type is the retaining wall that was built with bricks, and we call it brick masonry retaining wall, as you can see over here. And the third type is the reinforced soil wall, yeah. And the fourth one is stone retaining wall, which we built using the stone. Okay, so next I will talk about the retaining wall that was built in the past. And around 500 years ago in New Grand Crane, which is an ancient community in modern days Ireland. At that time, the retaining wall was built by stack of rounded stones, layer of grass turf or mat were placed. Okay, retaining wall also can be found in few Mesopotamian ziggurats. Ziggurats are the heavy pyramid type monument that made of clay. Okay, as you can see in the picture here. So up until 20th centuries, most of the retaining wall were built either use some sort of local material such as stone or imported woods. Okay, so retaining wall was also being used for railway and port in that time. Okay, as well as in 20th century, the design and material of retaining wall was changed drastically. And one of the biggest change in 20th century retaining wall is that the widespread use of reinforced concrete. And with the use of reinforced concrete, the element can be precast and the retaining wall had higher sustainability. Okay, the gravity retaining wall during that time was made up from large mass of stone or concrete. This type of retaining wall were too simple and often fell under less than optimum condition. Okay, for this part I'm going to talk about the literature review regarding the retaining wall. Okay, so for the first researcher is SEAA. She found that at developing an understanding of optimal design solution for three types of reinforced concrete retaining wall, which are cantilever retaining walls, counterfort retaining walls, and retaining walls with relieving platform. Okay, so by using the genetic algorithm, the parametric studies were carried out to establish the rules for proportioning the wall's dimensions corresponding to the minimum cost points. Okay. In addition, the optimal cost of retaining walls type was estimated and compared to carve out with the best design alternative for a given height. Okay. Also, she found that the advantage of retaining walls with relieving platform, which are relatively new in India. Okay. So the next researcher I found is Inder Kumar. So this researcher found that the analysis for the behavior and optimal design of counterfort retaining wall and gravity wall in concrete dam. So he also said that the cost analysis against each design of wall is evaluated by using the volume of concrete and the amount of steel. Okay, so for the next researcher is Yash Chaliwala, and this researcher has found that the behavior and optimal design of two types of reinforced concrete retaining wall of varying height, which are cantilever retaining wall and counterfort retaining wall. And the cost analysis against each design of wall is evaluated using the volume of concrete and the amount of steel. Okay, so that's all for my part. Thank you.
Okay, my name is Haziq, and I will continue about the current materials of retaining wall. So first, we have the gravity retaining wall. The gravity retaining wall can resist the lateral ground pressure, and the gravity retaining wall relies on exclusively on its own weight. And the example of materials for gravity retaining wall are masonry unit, stone, and concrete. Next, we have the cantilever retaining wall. The reinforced concrete, precast concrete, and pre-stressed concrete are used to construct this common retaining wall. This retaining wall also can be built on site or prefabricated off-site, or we call it as precast. The next retaining wall is pile retaining wall. These walls are built by driving reinforced concrete piled next to one another. And this wall provides high stiffness retaining elements that can withstand lateral pressure in deep excavation. Next, we can compare between the current retaining walls. So for the gravity retaining walls, it is made of either stone, mentioned unit, or concrete, while the cantilever retaining wall is made of either reinforced concrete, precast concrete, and pre-stressed concrete. And the pile retaining wall is made of reinforced concrete piled next to each other. And they are all 3 meter up height, 10 meter and 6 meter consecutively. And for the strength of gravity retaining wall, it can resist higher lateral pressure, while for the cantilever, it can either build on site and prefabricated off site, which can save time and it is more workable. And for pile retaining wall, it can be used for permanent and temporary works. And for the weakness of the gravity retaining wall, there are many parameters such as a lot of pressure needs to be taken into consideration for the construction. And the cantilever, it requires more design and careful construction. For the pile retaining wall, it cannot withstand high pressure. Okay, so we can proceed to the future materials of retaining wall. So the materials that we are using is fly ash. Fly ash is a waste product produced through the combustion of coal in the generation of energy. We use fly ash because as of 2010, there are 750 million tons of fly ash were produced globally, and it is exceed the capacity of fly ash usage. So that means we produce more than we use. So to counter this problem, fly ash can be used in geotechnical projects as a fill material for foundation, embankment, retaining structures for its engineering properties. So how does it work? Retaining walls reinforced with geosynthetic materials and fly ash as the backfill materials display strong ability and low settlement as a moderate cost, allowing for a wide range of application. This is the picture without the geosynthetic materials. And this is the geosynthetic materials such as, for example, waste tires, biaxial geogrid, triaxial geogrid, and it is used to support the retaining wall. And different geometrical combinations were considered in order to improve the soil retaining wall's performance and reinforcement impact. And how does it help with sustainability? Okay, so the rising production of fly ash poses a significant obstacle for a long-term development, and it surpasses the potential and capacity to utilize the fly ash. So by using the fly ash and sand mixture for backfill for the retaining walls, plus we add the geosynthetic reinforcement, we can counter the increasing production of fly ash for sustainable development.
The next thing that I want to mention is about the technology and equipments of retaining walls. So in terms of sustainability of environment, there is a technology that is called precast retaining walls. Why they use precast retaining walls? It's because the material used are recycled. Precast plants reuse formwork, in itself a conservationist move, and in doing so reduce construction waste that would otherwise be generated at a job site. In addition, cementitious materials used in concrete often contains manufacturing byproducts such as fly ash and blast furnace slag that would otherwise find their way to a landfill. The next thing is because it reduces site impact. Since precast concrete retaining wall systems are manufactured off-site and delivered on demand, there is a significant reduction in truck traffic. Thus, noise, and also debris from formwork associated with poor in-place products. Because precast concrete retaining walls systems are modular and standardized, they are installed in a quicker fashion and result in reduced construction times and energy usage, noise and emissions from on-site equipment, and in reduced site impact. In addition, it also has natural materials. The cement used in concrete is made of natural materials such as limestone and clay. Most cement plants rely on nearby limestone quarries. Aggregates used in the manufacturing of precast concrete retaining walls systems are generally extracted and manufactured regionally. And also, precast retaining walls are also durable. The concrete is a very strong and durable material, which is a significant sustainable attribute. It will not rust, rot or burn, and has a service life of in excess of 100 years. So the next technology that is often used is self-healing concrete for retaining walls. There are two different types of self-healing concrete. One is biotic, which is a microorganism based, and also the second one is abiotic, which is a chemical compound based concrete. However, in terms of sustainability of the environment, biotic self-healing concrete is preferable. Why? Since abiotic self-healing concrete is made up of harsh chemicals such as cyanide-crylate, which is the process of producing cyanide-crylate is harmful to environment, where they pump a huge amount of toxic greenhouse gases into the air. That's why biotic self-healing concrete is preferable. The mechanism is when the cracks appear in the concrete, the water seeps in the cracks and the spores of bacteria germinate and starts feeding on the calcium lactate, which is converted to insoluble limestones, and the insoluble limestone starts to harden and as it fills automatically without any external aid. So it can last decades or centuries. This ensures that we shall never have to replace the concrete surface again during its lifespan. Therefore, the usage of natural resources such as aggregates and sand particles to be mixed with cement just to fill the gaps in the cracks is decreased. Thus, it decreases concrete maintenance. Where I just mentioned just now, there is no need for external aid.
Technology and equipment in retaining walls with regard to sustainability element of economy and social is that we use self-healing concrete in construction of retaining walls. As we know, most concrete structures are prone to crack. Even a small crack can greatly reducing the lifespan of a structure. Repair or maintenance of any concrete that is cracked is most time consuming, so that's why self-healing concrete technology is introduced. Self-healing concrete is a concrete that is made with mixing healing bacteria that will biologically produce limestone to heal cracks. This gets activated only when the concrete gets cracked, and crack open up the pellets, and incoming water brings the calcium lactate into contact with the bacteria. This crack will take 1 to 2 weeks to get healed with the self-healing concrete. With this technology, we engineers can save money on maintenance and not worry about structure lifespan, as the bacteria can be alive in concrete for more than 200 years. Secondly, precast concrete technology is introduced in retaining walls because it is more affordable than the labor-intensive pour-in-place technique. Also, the quality of the concrete retaining wall is the best given the monitoring and tightly controlled process from materials to relieving. Moreover, if the precast retaining walls technology are being used for a large project, the basic, fast and repeatable assembling of the panels introduce significant economies of scale, and also it is cost saving.